Question number 19, part A. State two conditions necessary for a body to be in equilibrium, and you get 2 marks. So one condition is we have sum of clockwise movement, sum of clockwise movements about a point must be equal. Must be equal to the sum of anti-clockwise and clockwise movements about the same point. So that is one condition. The other one is for a system of parallel forces. For a system of parallel forces, is in equilibrium, sum of forces in either direction is equal. Sum of forces in either direction is equal. So that is how you answer that, and you'll be able to get 2 marks. We go to the next part. Part B. Figure 13 shows an ununiform log of wood AB of length 4 meters. The log is held horizontally by applying forces of 80 newtons at the end A and 120 newtons at end B. So we have a diagram here. This is the log. We have point A and B. We have the forces or weights, which is 80 newtons and 120 newtons. Determine, Roman number A, the value of R. So the value of R is equals to the sum of the forces. So it is 80 plus 120 is equals to 200 newtons. So that is the value of R, the sum of the two forces. Then we have Roman number 2, the position of the center of gravity of the log from end B. So this, we are required to find this. So applying the moment of movements, clockwise movements equals to anti-clockwise. So we say clockwise movement equals to anti-clockwise movements. So we say let x be the distance from the pivot to point A. To point B. So we say this is x. So what we do, we say 80, not that point, 80. So this means that this is, since we are told the length of the log is 4 meters, so this is 4 minus x. So we say 80 multiplied by the distance from the pivot to A, which is 4 minus x, should be equals to 120 multiplied by x. So you can multiply here, you'll be able to get, this is 320 minus 8x is equals to 120x. You take 80 to the other side, so you have 320 is equals to, you add, you get 200x. So you divide both sides by 200. X should be equals to 1.6 meters. So that is the distance from the pivot to point B. We go to the next part. Part C, you are provided with a meter rule, a knife edge, and a mass M1. Roman number 1. Describe how the position of the center of the gravity of the meter rule can be determined using the knife. So how do you do that? You press the meter rule horizontally on the knife edge. That is the edge of the knife edge. The position where it balances on the knife edge of the knife edge is the center of gravity. Diagrammatically, you can show it like this. So this is your meter rule, which you press horizontally, and you position the knife edge where the ruler balances. So this is the center of gravity. So this is center of gravity. Roman number 2. Using the position of center of gravity determined in 19C, Roman number 1, and the mass M1, describe how the mass M of the meter rule can be determined. So what you do is you move, the knife edge, away from the center of gravity. Away from the center of gravity to a new position. So once you do that, note the distance from the knife edge from the knife edge and the center of gravity as D1. As D1. So once you do that, place the mass M M1 that is the mass provided on the other side of the meter rule. Of the meter rule. So once you do that, you adjust until the rule balances as in 19 Roman number. So Roman number, adjust it until we have until the rule balances, the meter rule balances. So once it balances as above, then you note the distance. Note the distance from knife and the mass M1 as D2. The distance, that is the distance from the knife edge and the mass M1. And that is, we are supposed to say knife edge, and the mass M1. M1 as D2, that is distance 2. So we say, using the principle of movement, using the principle of movement, we say that M D1 is equals to M1 D2. So our M is equals to M1 D2, and you divide by D1. You divide by D1, where M is the mass of the meter rule. So we say where M is the mass of the meter rule. So that's how you answer that question. You'll be able to get 4 marks, and up here you'll be able to get 2 marks. So that is how you do that question.